Okay, let's remember the precise definition of the limit. We say that the limit as x approaches c of f of x is equal to L if for every epsilon greater than 0 there exists a delta greater than 0 such that when the absolute value of x minus c is less than delta, this will imply that the absolute value of f of x minus the limit will be less than epsilon. Oops. Epsilon. Okay, so let's just take a generic function here, like so. This is f of x. And let's say we're looking, the limit as x approaches c, so we'll pick a value for c, let's say here, trace this down. That x value there will be c, and as we come across, we will say that this value will be epsilon if a couple things happen, right? So I can look some distance around c, say here and here. Okay. Now what is this distance? This distance here is going to represent delta, both on the left and the right. Okay. So that would force this point over here to be c plus delta, and this point over here to be c minus delta. Okay. So when I do that, I can trace these up. This will come a point, and as I come over here, we also get a function value, and as I come up here, I get a function value that's above the limit. Now, what do we want these distances around the limit to be? Well, those are going to be epsilon. So here's an epsilon above and below. So that forces this line to be the limit minus epsilon, and that forces this line up here to be the limit plus epsilon. So that's in general. Now, what we are given in this problem is that we want the x absolute value of x minus 1 to be less than delta. If this, then we will have the distance between f of x minus the limit, which we are saying is 1 in this case. So this is the limit, and that needs to be less than epsilon, which they're giving us as 0.2. So this is epsilon. This is also our c up here. So on the diagram, we can look at it, and the function looks like so. It's a decreasing function. And they tell us here is c, which is equal to 1, and when we trace that up, we come over to the limit, which they're also saying is equal to 1. Okay. Now, they haven't told us what delta is. We are supposed to look for it, right? But they do give us a few points. One is up here. The value here they give us is x is equal to 0.7. You chase that up, come on over. The function value that comes out is 1.2. And then notice how far is this in between. This is 0.2, which is equal to our epsilon. So that works. Now let's see what's happening on the other side. On the other side, what they give us then, well, first, before we do that, so what's our distance in between here? Our distance in between here is 0.3. Okay, so this is a possible value for delta. Now, then they give us another value over here, which is 1.1. That tells us here's another possible value for delta. This is where delta is equal to 0.1. And if you trace this back up, you find the function value associated with that. That value is 0.8. And it works out inside of here that that distance in between there is still epsilon, and it is 0.2. So we have two options for delta. Is delta equal to 0.1, or is delta equal to 0.3? Now, we want this to be for every epsilon greater than 0, there will exist a delta greater than 0. So when we're faced with this decision, we want to make sure that we pick the smallest delta because that will force the inequality to be the inequalities to be true. So if the absolute value of x minus 1 is less than 0.1, then for all values, the f of x minus the limit, which is 1, will be less than 0.2.